All right, let's take a look at the special problem for Chapter 9. So at Dicey Dan's Diner, the dinner buffet usually costs $9.99. Once a month, Dan sponsors Lucky Buffet Night. On that night, each customer can either pay the usual price, $9.99, or roll 2 fair 6-sided dice and pay a number of dollars equal to the product of the numbers showing on the 2 faces. Question A, find the probability that a customer who decides to roll the dice pays more than the usual cost. Okay, so this is what I love about the special problems, and this is what you should expect on the FRQs for the AP exam. The setup is nice setup, but you're going to be asked things that kind of cover more than one chapter. So question A is not from Chapter 9. This is more of a Chapter 7 question. But that's okay. We've mastered Chapter 7. So in order to answer this, we got to make a sample space. I could roll my 2 dice and roll double ones, and then I'd only pay $1. Wouldn't that be great? I could get a 1 and a 2, a 1 and a 3, 1 and a 4, and so on. Now, we've made this distribution before, but normally we add the 2 numbers like when we're playing Monopoly. In this case, we're multiplying them. But that's okay. We can still do it. And sure enough, just like when we add them, we're going to get a sample space with 36 outcomes. But instead of by multiplying, we get values that range from 1 to 36 instead of between 2 and 12, right? But there's one way that you would pay $1. There's one way you would pay $36, right? There's 2 ways you would pay $3, and then 2 ways you would pay $30, right? So on and so forth. Now, let's answer the question. What's the probability you end up paying more than the $9.99? Well, just count up all the ones that have a product greater than $9.99. And that's 10. And there we go. So that is 19. So out of 36. Probability that a customer pays more than $9.99 is 19 out of 36. There you go. Question A. That was fun. All right, question B. Here's where it shifts gears. Now, a group of 40, right? So we're not talking about a single customer. Now we're talking about 40 customers gambling on the buffet. Here's where we now shifted gears to Chapter 9. What is the probability the total amount paid by the group is more than whatever? So on this, first we need to find, well, what's the mean for one person, right? What's the mean of the distribution? So, 1 plus 2 plus 3 plus blah, 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 add those all up, divide by 36. Now, to do that quickly, I actually just entered all of those products into list 1. And then I'll just do a quick one variable stats, and there we go. The mean is 1225. So the average result of one roll is 1225, even though you can't get that on one roll. Remember, we talked about that a lot in the past. And there is our standard deviation. Okay, now to get the standard deviation, remember, it is on the formula sheet right there. Okay. But what we do is we take each outcome, we subtract the mean of 1225, and we square that. And we multiply that by the probability of the outcome. Okay. Then we take the sum of all of those and square root it. And that's how we got that standard deviation. And notice I'm labeling these with x, not x bar, because these are parameters, right? These are theoretical. They're from the theoretical distribution, right? They're not sample data. Okay, now we're going to make n be 40. Okay, so this is dealing with one person. Well, what if we take the average of 40? Okay, well, the average of 40 means that my mean of x bar, well, guess what? My mean of x bar is still 1225, right? We have a formula that says the mean of the sampling distribution of x bar will be equal to the mean of the distribution. Okay. Now, the standard deviation, however, does change because, remember, as sample size increases, the variation decreases. And the relationship is divide by the square root of n. So there's now my mean of 40 and my standard deviation of 40. Okay. Now, if I have normality, I can use a z-score. So the question is, would I have normality? Well, we're talking about x bar, right? Sample size of 40. So central limit theorem will give us approximate normality. And there we go. Okay, now, is it safe to use our formula for standard deviation? Yes, of course, because in theory, we could roll the dice as many times as we want to roll the dice, okay? All right, let's do the problem then. So we want to find the probability that x bar is greater than 439 and 60 cents. Right? This we're talking about x bar, so that divided by 40, that's my x bar, right? Okay, so let's get a z-score. 439.60. That works out to be $10.99 a person. And 1225 is the mean of the distribution, and the standard deviation. There we go. So work out your z-score. I got negative 0.8911. That's 8, which gives me a probability of approximately 0.81358. Okay, so, all right, for some reason the recording stopped there. Let me pick it up. So the probability that the total paid by the group is more than this. There we go. Okay, on to question C. What is the probability that more than half of the party of 40 pay more than the usual cost of the buffet? Okay, so we're now shifting gears again, and we're hitting chapter 8. So we've done chapter 7, chapter 9, and now chapter 8, all on this same problem, just by changing things around slightly. All right, so go back. The chances that one person pays more is right there. So we want to find the chances that more than half. Okay, well, this is binomial. N is 40. The chance for a single person is 19 out of 36. And we want to find the probability that x is greater than half, so greater than 20. Okay. Remember, being binomial, that means start at 21, right? So this is the probability that x equals 21 plus the probability that x equals 22, and all the way out to all 40. Whoops, x equals 40. Okay, and showing the work, 40 choose 21, 19 out of 36 to the 21st, 17 out of 36 to the 19th. And so on and so forth. Okay, so that's the work. Now, how would you actually do it? Well, my calculator has the binomial CDF, which is a less than or equal to only on my calculator. So I have to do the complement. So to do it, I would actually do 1 minus the probability that x is less than or equal to 20. Okay, again, pay attention to the boundaries, right? If I want greater than 20, the complement is less than or equal to 20. So that's what I want to do. Put that on in the calculator. N is 40, 19 out of 36, and 20. And there we go. So the probability that more than half pay more than $9.99 is approximately 0.570. And there you go. So make sure you guys are ready for the test, and good luck studying.